Good morning, good afternoon, good evening, wherever you might be, and welcome to a science post on Simpson's paradox and how it applies to physics and love. Now, if you come from the data science or machine learning community, you would you would be very familiar with the Simpsons paradox. But if you come from the physics community, or any other community, you probably never heard of it. Yet, if you apply it very generally, it illuminates a lot of things that are puzzling within physics and other fields as well. So, what you see behind me is a chart describing body mass index as a function of how much pasta a person eats per day. And what's interesting about it is that if you look at a single color or subset of the data of these populations of people who eat pasta, you would conclude that eating more pasta every day will make you thinner because the line is sloping downwards. But if you look at all of the data grouped together for all people, you'd be forced to conclude that eating more pasta every day will make you fatter. So, how can this be? How could it be true for a subset but false for the general case? Perhaps the body can't process infinite amounts of pasta because it will just run right through you after a certain point. Whereas generally, for a large group of people, those who eat less pasta are thinner. Surprisingly, this very same mistake in reasoning is at the root of many mysteries used by the physics community to recruit students and ask for research dollars. If you look at this chart and you just replace space and time, or particle and wave, or matter and antimatter with the pasta and fatness axes, you might start to understand. But because it isn't, you have to think about it a little bit. I'll try to break this down. When physics students are taught about quantum mechanics or relativity, they are taught to make incorrect causal inferences based on two-dimensional approximations of three-dimensional systems. Off the screen here. And this lack of awareness of their blind spots leads them to believe in silly concepts like contracting trains and tunnels, entanglement, and multiverses. These blind spots and confounding variables are responsible for our uncertainty about everything from the position of a particle to the presence of free will, to the existence of gravity. Because if you don't know the initial conditions of a system, you won't be able to predict these things with perfect accuracy, no matter how good your theories are. It is far too easy to confuse people about these matters by speaking in several distinct, self-consistent yet inconsistent languages at the same time. And that is why when you teach physics or any other discipline, it is important to be able to translate the textbook language into several other languages from other disciplines so that you can check for consistency with concepts that everybody understands. That way you can keep the student grounded with their intuition while strengthening their ability to visualize. For example, when a physicist says that There is a mystery about why there is an asymmetry between matter and antimatter. You should ask yourself if the mystery becomes clearer when you translate this statement into the language of energy. If matter is positive energy and antimatter is negative energy, then an asymmetry between matter and antimatter means that energy is not conserved over the length scale on which an asymmetry has been observed. Similarly, if there is more matter than antimatter over a certain length scale, then there will be positive entropy. And if that length scale is the size of the universe will spread out and die a long, cold heat death. If the universe represents the information economy, when more people talk at the same time, the less anyone can be heard, and censorship isn't even necessary because no one can hear anyone else. The communication channels become overloaded as we accelerate through a sort of information bottleneck. Alternatively, if there is more antimatter than matter over a given length scale, there will be negative entropy and life will flourish. The growth of a person or tree is a negative entropy process, and whenever a system is being fed with an outside source of energy, for example with an oscillation of space itself, you can have negative entropy or decreased disorder. If you think about how words have been co-opted and corrupted over time, the root meanings begin to emerge. Positive energy is coherent, synchronous motion in a visible direction. Negative energy is coherent, synchronous motion in an invisible direction. Positive entropy is an increase of visible, coherent motion, and negative entropy is an increase in invisible, coherent motion. This is a sort of translation of physics language into the language of psychology or blind spots. What is visible depends on your perspective, clearly, or length scale, as when you attempt to look at the ocean between the waves. When it is everywhere, it becomes less visible. One can shorten these definitions by reintroducing certain forgotten words like exergy and extropy, such that energy gives rise to extropy and exergy gives rise to entropy. You can even quantify this with a variable k, which in the language of Wilfred Bion, it represents knowledge or information, and it connects to quantum theories of information and the psychology of Wilfred Bion. He was someone who worked in the post-World War I era. What I'm trying to do here is show that we have theories of everything. We just don't have a common language anymore because everyone insists on speaking their own private language, but it's possible to translate. And I think that's worth doing in the classroom. Because in the classroom you have the psychology teacher, you have the physics teacher, you have the economics teacher, and they all speak their own languages. I don't think this is necessary. I think this is maybe a little bit counterproductive. The more I read, the more I see the possibility of dramatically simplifying and combining languages. Then again, if language is an ecosystem, having a wide variety of redundant languages makes it more difficult for key concepts to be lost during a disruption. If one language is infected by a worm, another, equally good one might take its place. This is all well and good as long as we operate with an awareness of the divisions between the languages. When, as in physics, people speak of space and time without knowing that those words have been used in very different contexts within different branches of physics, the entire discipline becomes infected with absurdity, whereas the divisions between these contexts may be maintained by quarantining them within secondary and graduate education. The college curriculum and science popularizers have mixed them up to an embarrassing degree. And this infects those who are in the classroom. So you'd think that this sort of conflation wouldn't have an effect on a smart person, but it's kind of like mental malware. You get infected with it, and it's hard to disentangle once it's taken root. It's like a weed that grows in your mind. A person might respond that these questions of unified language don't matter to anyone outside of the academic physics community, but they've probably not considered the profound psychological implications these matters have for how we view ourselves and our place in the world. If you believe that the universe is ruled by negative entropy, eternally expanding and destined to die a cold, lonely heat death, you will feel small and isolated. You may despair of ever having an impact on the world, and you will be easy to control by those who lack this perspective. If you believe that the universe is ruled by positive entropy, you will feel supported by an unseen force that drives everyone forwards to an unknown end. You will feel like your choices are supported by a collective, and you will be difficult to control by someone who wants to micromanage things. If you believe that there is a continual exchange between positive and negative entropy over different length scales, you will continually adapt yourself to new perspectives as required. These questions of language also have profound implications for how people view their own intelligence. If everyone is speaking a strange language that you can't understand, you are going to feel stupid until you figure out that once you translate the many languages of physics into simpler, more basic terms, the concepts are embarrassingly simple, and that physicists should be ashamed of themselves for using such a stupidly redundant, overly complicated language that contradicts itself. Then again, teaching certain people to speak in coded languages has its uses. I enjoy studying these issues because of the prismatic structures that emerge and delight my mind's eye. I see the language of physics in religion, in art, in psychology, in biology, in love. When you love someone through their connection to the absolute, you love an ocean between the waves. They represent everything to you. Their particular features don't matter that much because you both love your connection to something greater than you. Compartmentalized concepts like Simpson's paradox from data science need not obfuscate and stand in the way of this sort of unified understanding. If I apply Simpson's paradox to love, I see that it is possible to hate someone in a moment, but love them overall. In psychology, this concept is called object constancy, and it is closely related to object permanence, the lesson you learned when you played peekaboo with your mother when you were a baby. So, I hope you enjoyed this attempt to connect love, physics, and pasta. For more unusual perspectives on science and culture, please check out my other videos. I think I've made 160 of them now. And if you prefer reading things, they're also in blog post form with lots of nice pictures and links and videos. If you prefer things in a more whimsical, fictional form, please check out my novels. They are, I think, a lot of fun, and someone suggested that the title I chose was terrible and that I should change the title of my novel to Information Theory, a Novel. I kind of like that. It's not a bad idea. So, until next time.